Hey guys, welcome back to another video from the channel Learn from Basics. This is Joe here, and in today's video we are going to learn about object detection. And we are actually going to make our first object detection program using Opencv. And YOLO, you only look once. So without any further ado, let's get right into it. So what are we going to use in this program? Well, we are going to use a combination of YOLO, you only look once, Python, and the PyCharm is the text editor we'll be using, Opencv, and NumPy. Now, we'll talk about how to include Opencv and NumPy in our program later. It's actually really easy. But let's download YOLO, because we need YOLO in order for the object detection, because that is where all the formulas and algorithms are in order to detect a certain object. So, in order to detect YOLO, there will be a website that I'll link down in the description. And if you can go to that website, you'll be greeted with this page. Excuse me. So now, as you can see, there's some information. You can read it over here. And then we have many YOLO versions over here. So these are all the YOLO versions. We have YOLO 320, YOLO 416, YOLO 608, YOLO Tiny, and YOLO SPP. So now you can download any YOLO you want, any YOLO version you want. It really doesn't matter. YOLO V3 Tiny is actually really fast. As you can see, the frames per second is 220 frames per second, but it's not so that accurate. So you can see it's only 33.1. Whereas YOLO V3 608 is pretty accurate at a steady 57.9, and its frames per second are also pretty good at 20 frames per second. Now again, as I said, you can use any YOLO version you want, but I will be downloading the YOLO V3 608 version. So in order to download this, you simply click on the weights to download the weights. And for the config, it's actually pretty tricky. So when you click on the configuration page, it takes you to this GitHub repository. So it takes you to the PedReady Darknet repository. And now, as you can see, the first thing we're going to do is we're going to fork this so we can download whatever we want. And now, you can download this as a zipped file and unzip it, but I'll just tell you the files that you'll need. So go to config. Now, as you can see, when we go to config, we have some files. So if you downloaded the YOLO V3 version, if you downloaded the YOLO V3 version that I downloaded, then you should be fine by just downloading the YOLO V3 config. Whereas if you downloaded the Tiny, we have the Tiny over here, the SPP, we have the SPP over here, and etc. So whenever you click the config, it shows you which file is the configuration for that YOLO version. And then we also needed another file from this Darknet repository. So now, when we go to data, you can see there are many files. But we'll need this coco.names. Now you might be wondering, what is coco.names? Well, it's basically a list of 80 objects that Opencv has already been pre-programmed to detect. So it can detect person, bicycle, car, motorbike, airplane, bus, train, truck, etc. So you can read all of these. And again, there is a way to add your own custom objects that you can detect. So if you want to detect a Samsung iPhone, then you can do that. So I'll tell you how to do that, but that's for another video. So after you download this and put everything in the file should look something like this. Hey guys, so after you have downloaded everything and created a file, your file should look something like this. So you have the coco.names, you have the image. So this can be any image you want. I'm just using this image of an office because there are a lot of objects in this image that Opencv can detect automatically. And then we have our PyCharm file or file. And then we have the YOLO V3 configuration. And then we have the YOLO V3 weights. So now after you have put all of this into a folder, what we're going to do is we are going to open this main. So we're going to open the PyCharm file. And now as you can see, after I opened it, you can see over here under the object detection folder, we have cocoa.names, which is a list of all the things that Opencv can detect. We have image.jpg, our image. We have our the area where we write our code. Then we have configuration and weights file. Now, first, let's import Opencv. Let's import Opencv and NumPy because we need both of those libraries per se in order to do this. So we're going to say import cv2, and then we're going to say import NumPy, and then in order to make it easier to type every time, we're just going to say npy as npy. Now, the first thing we're going to do in our program is we're going to copy all the things that the names of all the things that Opencv or YOLO can detect automatically into a list. So in order to do that, we're going to create a list. So names, let's name it names, equal to, and then we're going to create a list. And now we're going to copy everything into that list. So we're going to say width, open, and then the file name, which is cocoa.name. Oh, God. So we're going to say cocoa.names. And then since we want to read it, we're going to say R. And last but not least, we're going to say as f, and then names equal to f.read. And then since we want each line to be a separate name, we're going to say dot split lines. So now, let me close that. Now, if we can run this program, so we're going to say print names. We don't need that. Now we're going to open this, and after we run this, you can see we have the names of all the things that Opencv can detect or YOLO can detect. So now let's comment that because we won't be needing that. So the next thing we're going to be doing is we're going to bring our image into our program, and we're going to store it in a variable. So we're going to say image as our variable, and then we're going to say cv2.read or imread, and then we're going to say the file name. So as you can see, my file name is image.jpg. And now our image should be stored in this variable, but let's make sure and let's print this image. So what we're going to do is we're going to say first cv2.imageShow, show, and then we're going to say this is going to be an image, and then the variable we stored the image is image. So we're going to type in image. Now we're going to say cv2.waitKey, and our delay is going to be 0 because this is an image. And then last but not least, to end our program, we're going to say cv2.destroy all windows. cv2.destroy all windows. So all windows. Now, if I can run this program, you can see that our image is displayed over here as an image. So now, what are we going to do next? Well, since we have our image stored in the image variable, we now have to pass on our image into YOLO so it can analyze that image and send us back data. So the first thing in order to do that, the first thing we have to do is we have to convert this image into a format that YOLO can recognize. But before we do that, this is actually going to be for later, but we're just going to name a variable called height. I don't know if I'm typing that in right. Height, and then we're going to say width, and then we're going to say underscore equal to, and now we're going to say img.shape. Now you might be asking why. Well, I'll tell you why we're going to use these variables later on in the video. Now, we have to turn our image into a format that Opencv can understand. So how are we going to do that? Well, we're going to say blob as our variable, so this will be where we store our new image. And then we'll say cv2 dot dnn dot blob from image. And now what we're going to do is, first we're going to tell the program where our image is stored, where our original image is stored. So we're going to say image. And then we're going to say how much we have to convert it. So we're going to say 1 to 255. And then so as you can see, this is the size. And then we say our mean, which is 400 and, so actually just this. So now we're going to say our mean. So as you can see on top over here, it says, so this is our scale factor, and our size is going to be 416 by 416. 416 by 416. And then our mean is going to be none or 0, 0, 0. And then we want it to swap RB. So we're going to say swap RB as true. And then we don't want to crop this. We don't. So we're going to say crop as false. And there you go. And as you can see, let's format this because Python apparently doesn't like it like this. That's why it's showing us the errors. That's just because, so these yellow lines, that's just because we're not formatting it correctly. So now we should have 0. So now, as you can see, we have this blob. And now next what we're going to do is we're going to turn this blob, or we're going to make our computer show us a side-by-side comparison of the original image and the blob. So we're going to do that right now. Hey guys, so now, as I said, what we're going to do is we are basically going to make the computer display our new and converted form of our original image, and we're going to basically compare it. So we're going to write some simple for loops in order to make this happen. So for and b in blob, and then we're going to write a nested for loop, and we're going to say for n and then image underscore blob, this is in, and then we're going to enumerate b, and then finally we're going to display it. So we're going to say cv2.imShow, and then we're going to turn n into a string, and we're going to finally say image underscore blob. Now if I actually run this, you can see that I have 3 images. So we're actually going to delete 2 of them, and we're going to compare both of these. So as you can see, number 1, the color's off, that's obvious. And number 2, the dimensions are off. So you can see this one's longer than this one, and this one's thicker than this one. So that's basically what it is. So we basically converted this image into this image so Opencv can process it. So now you can comment this, but I'm just going to delete this. And now there's actually another important thing to do. So you know how we downloaded YOLO v3 config and YOLO v3 weights? Well, now since we have converted blob, since we have converted our image into blob, we have to send our blob image to YOLO. So to the YOLO v3, so we can process it and return some data. Now, in order to do that, we need to link the YOLO v3 config and YOLO v3 weight files to our program. How are we going to do that, you ask? Well, we are going to do this via a variable. So I'm going to name this variable net. So actually, let's do that under NumPy net. And now what we're going to do is we're going to say cv2.dnn.readnet. And now what we're going to do is we're going to read the files YOLO v3 dot weights. I think that's it. And then we're also going to read the files YOLO v3 dot cfg. So now since we included both of these files, the YOLO v3 config and YOLO v3 weights, into our program, we can continue. So now, as I said, let's send our blob image or our converted image to the YOLO v3 so it can process it and return us some data. So what we're going to do is we're going to say net dot set input, and now we're going, as I said, we're going to send the blob image. And now we're also going to say output layers. Output layers. So output layer output layers names. So we're going to say that. And this is again a variable. And inside this we're going to say net dot get unconnected out layers names. So we're basically getting the names of the layers. So now since we got that, so we sent the net dot set input. We sent this image to YOLO v3. Now we're getting back the data so we can format an image that has all the objects detected. So this YOLO v3 actually sends all the data back in, well, let's say groups. So now we have the confidence level. We have the box itself, so where the box is located. So we have the box's X, Y, width, and height. And then we also have the name. So what we have to do is we have to collect all that data and we have to put that data back on the image so we can do the object detection. So now we're also going to have another variable called layer output. So these variables are going to be very important in the future in this program. So name these variables however they make sense to you. So we're going to say net dot forward output layers named. Now, as I said, what we're going to do is we are going to get back all the data of where the boxes are located, the confidence of each box, and the class IDs. So what the name of each box is. So in order to do that, we're going to make arrays. So we're going to say boxes. I'm sorry, I'm so confused. We're going to make lists. So we're going to say boxes, and then we're going to say confidence. And then last but not least, we are going to say class underscore ID underscore values. And let's actually make these confidence value. Now, what are we going to do? Well, we are going to write a for loop in order to retrieve all of this data. So we're going to say for output in so we're going to say for output in layer output, and then we're going to write a nested for loop, and we're going to say for detection or detect in output. And then inside this, we're going to write our program. So first of all, we're going to say scores. So we're going to basically write scores, and we're going to say detect and 5. So I'm actually going to explain what all of this is going to mean after we finish this section of code. And then we're also going to say class IDs, class underscore IDs is, so we're going to say class IDs is going to be np.argmax, and then we're going to say scores. So we're going, I'll explain what this means after we finish this snippet of code. And then we're also going to take the confidence, or how sure the computer is that how sure the computer is that this certain object is a chair or etc. So we're going to say confidence equal to, and we're going to say score of class ID. Now, scores, I'm sorry. Now, we don't want our computer to show every object that it can detect, because some objects it detects wrong and it's not sure. So for example, it might look at a chair that's slightly visible and it might confuse it for a computer. And so when it does that, when it's confused on whether it's a chair or a computer, its confidence value will be really low. So that's why we need to limit on how much our confidence value has to be in order for the object to be recognizable. So what I'm going to say is I'm going to say if my confidence value is greater than 50%, then only can you confirm that is the object you're thinking. So if it's 0.4, no, that's not the object you're thinking. So we're just trying to make sure that every object that YOLO detects is going to be accurate. So we want the accuracy of each and every object to be greater than 0.5. So we're going to say if confidence greater than 0.5, then only am I going to read all the data that's connected to it. So now let's read all the data that's connected to it. So we're going to say X center point is going to be equal to, well, first we're going to turn this into an integer, and then we're going to say detect of 0. Now, do you remember how we converted our original image into a blob? So when we get our output, we don't want the output to be in a blob. We want the output to be in the format of our original image, right? So what we have to do is we have to slightly mess with the X center point values and the width and height of these boxes in order to make it match our original image. So how are we going to do that? Well, do you remember how we took the height and width value of our original image? Well, that's because we want to turn our blob image into our original image again. So we're going to say X center point. So we're going to say detect of 0 times height. Times width. Oh, my typing is... Now we're going to do this again. And now instead of X center point, we're going to say Y center point. And again, we're going to say detect of 0. Actually, no, it's not a detect of 0. It's a detect of 1. And now instead of width, we're going to say height. Now, we also need the width and height of the box. So we need to know how long and how wide the box is. So the X and Y just show us where the box is located on the picture. The width and height show us where the box is, or how wide and how tall the box is. So how are we going to do that? Well, we're going to use a variable. We're going to say box h equal to, well, let's start off with width, and we're going to say integer, or turn into int, and we're going to say detect of 2 times the width, the original width. And then we're going to do the same thing over here. Detect 3, and instead of width, we're going to say height. And again, this is not going to be box of W, this is going to be box of H. So, now, so there we have that. Now, our last value that we're going to have is we are going to slightly, so what we want to do is we want to have our X and Y values too. So we're going to slightly modify our X center point and Y center point values, and we're going to slightly modify them to, again, as I said, to make them match our original picture. Because again, all the data that the YOLO is sending us back is based on the blob image. So right now we're just converting all the blob image values into the original image values. So we're going to say x value equal to, and then again we're going to turn this into an integer, and we're going to say x center point minus the width of 2. Box width of 2. Box width of 2. And then we're going to do the same thing as the y value. For the y value, so we're going to say box height this time. That's a capital H. And now, instead of x center point, we're going to say y center point, and then we're going to say y value. So now, as you can see, we have the modified value over x and y. So x and y, they're basically there in order to tell us where the box is in the picture, and the box width and box height variables are there to tell us how wide and how high the box is, or how tall the box is. Now since we have all of the values over here, let's basically add all of these values into their corresponding arrays. So we're going to add the confidence values into our confidence values into the confidence value list, the class IDs value into the class IDs value list, and the boxes values into the boxes values list. So we're basically going to use the append function. So we're going to say boxes dot append. And now again, as I said, we want the boxes to have we want the boxes list to hold the height of the box, the width of the box, and the x and y values of the box in order for us to know where the box is located. So that's exactly what we're going to do. So we're going to say x value, comma y value, comma box height, box width, comma box height. And then, as I said, we're going to make these, we're going to comma this so Python likes it. Well, and now we're going to do the rest, we're going to do this for the rest. So we're going to say confidence values dot append, and we want to append confidence. So we're going to append the confidence. And now last but not least, we're going to say class IDs value. And then we're going to say dot append. And then we're going to append, the class ID. So as you can see, the class IDs. Now, nothing much is going to happen, but I'm just going to run it in order to see if there are any errors. Good to know, there are no errors. So that's our code, and as I said, as I promised, I'm going to explain what all of this is. So let's go into the explanation part real quick. So here's a quick explanation. So the scores, what we're basically doing is we are detecting all of the boxes and all of the objects that were detected by YOLO. So we're basically getting all of that and storing it in the variable scores. Now the np.argmax, what we're doing is we're going to look into all of the scores, and we are going to bring out only the ones with the highest. We're only going to bring out the ones with the highest confidence values. And over here again, we're assigning confidence the highest confidence values, and then we're doing them one by one. So as you can see, class IDs. So we're doing them one by one, and then over here we're checking if the confidence of that particular object is greater than our minimum threshold, which is 0.5 or 50% confidence. And then over here, as I said, we're just basically if it's greater than 50%, we're taking all the values and we're converting them so they match with our original picture, because all the data that it's sending us, that YOLO v3 is sending us, is data that applies for the blob picture that we sent. So we're converting that back to our original picture, and we're storing that in the boxes.append, or all of the arrays. Now, on to our next part, which is our final part of, displaying everything. And again, as I said, I will be explaining what each and everything is at the end of the code snippet. So we're going to say indexes, so this is a variable. And we're going to say cv2.dnn dot nms boxes, nms capital nms boxes, there we go. And now what we're going to do is first we're going to type in our boxes, so wherever our boxes are. So again, all of our boxes values are in the boxes, so we're going to say boxes. And then our scores, or our scores is basically our confidence value, which again is in the confidence values array, so we're going to say confidence values. And then basically what we have is our minimum threshold, which is 0.5. And then finally we're going to enter 0.4. So again, I'll type this out again. Indexes equal to cv2 dot dnn, and then again the nms boxes is caps. And then as you can see over here, we have all of the things we have to give it. So as you can see, NMS threshold, and then we have ETA, and then top K, and we don't need anything. So I'm going to delete that. So now we have our indexes down. What we're going to do next is, when we display our output, we need to give each and every box, or we need to color code each and every box. So we need to give a color for every box that contains a person. We need to give a color for every box that contains a bicycle. We need to give a color for every box that contains a car, and etc. So you can color code it if you want, but all I'm going to do is I'm going to say colors equal to, so color equal to np dot random. So we're going to have a random color, but we're going to make it uniform for each and every class. And then we want our random colors to be from 0 to 255. And then we want the size to be the length of the boxes, so len of boxes. And then last but not least, we want the width to be 3. Or that's what I think. So I think this is the width, but don't quote me on that. And then over here we're going to add our font, so font variable equal to, and we're going to say cv2 dot font, and you can choose any font, as I said. Honestly, any font looks good, but I'm just going to say font Hershey's Complex, because I've tried this before and I think this font looks the best. And now we're going to write a for loop in order to display everything in the correct place. So for so before we do that, let's actually print all of our indexes over here. So we're going to say indexes, and then we're going to say indexes.flatten. Hopefully no errors, please, please, please. And we have an error. So as you can see, returned null without setting an error. Now this actually happens many times. Many people will probably get this error. So let's see what we did wrong. So the first thing that I would check is if you got all of the values correct. So do you have boxes over here? Well, yes, you do. And then do you have confidence values? Well, yes. And then you have 0.5 and 0.4. So we're going to go up here and we're going to see if we got everything correct. So what did we get wrong? Well, I don't see anything we got wrong as far as I can see. So yes, I spotted the error. So I'll give you some time to think about what the error is. And actually many people face this error when doing this, so you have to be careful. Because again, as I said, many people face this error. I faced this like 10 to 20 times. So what is the error? So have you spotted the error? Well, if you haven't, that's okay, because let's discuss this error. So the reason we're getting this error, so let me run that again. The reason we're getting this error actually is because, well, this function, the NMS boxes, it returned null without setting an error. So you might be wondering, what does that mean? Well, to simplify this, what it basically means is so all parameters in this function should be integers or floats. They shouldn't be strings or characters. So our problem over here is that, well, if we go up here to the confidence values dot append variable, we can see that our confidence, even though common sense that says that this is a integer, it's not an integer. It's a string. So our confidence is a string. So when we append it, it becomes a string. So what we have to do is we have to specifically mention to the computer that whenever we append the confidence variable, we don't want it to become a string. Instead, we want it to become an integer or float, or in this case, a float. So how are we going to do that? Well, first of all, we're going to put confidence in 2 brackets, and now we're going to turn it into a float, which is easy. You just say floats, and you cover it up in 2 brackets again. Now, you should be able to do this. And while I was going through the code, I also noticed a really, silly error, let's say. You might be wondering what that is. Well, over here, you can see I typed indexes. So you actually don't say indexes and then indexes dot flatten. You're supposed to say print and then indexes dot flatten. So now if we run this, it's going to be error free. And as you can see over here, we have all the indexes printed. So you can count these. So you have 0. We're missing 1. So like that, you can count those down. And now let's stop this. Yeah, it stopped. So now what we're going to do is, next, we don't need this function. You can comment it if you want. Now, as I said, we are going to write a for loop in order to put down everything on our original picture, in order to gather and organize all of our data. So in order to do that, we're going to say for I in, again, we're going to use the indexes.flatten function. And then what we're going to do next is we are going to get the x, y, height, and width from our box. So you can see we already put all of those down, x value, y value, box, w, box, h. We actually put those all down, so we're going to get them back. So x value, y value, box width, and box height. So now we're going to get all of those variables down from the boxes of I. And now what we're going to do is next, we're going to get ourselves a label. So what is a label? Well, that's basically the name, or the name or whatever object, the name of the object inside the box. So we're going to say label is equal to string. So we have to convert this into a string. And then as you can see, we're going to use that names array we made, or we're going to use the names list we made earlier. So names. And then what we're going to do is we are going to say classes ID. So we're going to say names of class IDs. So whatever class IDs, and then we're going to say of I, because we want the class ID to be, we just don't want every single name inside class IDs. We just want the one of I. So as I said, this is simple. We just take the class ID and we search for that class ID in the names. Now we have our label down. The next thing we want is our confidence value, or our accuracy. So for the accuracy, we simply say accuracy, and we want this to be a string too, so we're going to turn it into a string. And then we want our accuracy to be rounded. We don't want it to be a long number, so we're going to say round. And then we're simply going to say confidence values of I. And now finally, for the color, which is again really easy. Color is color. So we're going to say colors is color of I. And then last but not least, we have 2 more commands until our whole program is done. What are those? Well, first we have to create the rectangle. So we're going to say cv2 dot rectangle, and now we have to give this rectangle some input fields, like the image. What image? So our image is simply image, and then our point 1, which is going to be our x and y. So our x and y is x value and y value, and we have our point 2, which is going to be basically the width and height. So it's going to be the width and height. So we're going to say x. So it's going to be point 2, which is going to be x plus w and y plus h. So these are basically the corners. So these are the bottom left and right corners, and these are the top left and right corners. So this is going to be x value plus box height. Box width, and this is going to be y value plus box height. Now, since we have this done, our next thing is going to be, well, the color. And our color, we can simply say color. Well, we have our colors variable, so that's going to be our color. And the thickness. So this is important. I'm actually going to put a thickness of 3, but you can put whatever number you want. Now, last but not least, we have our label. So in order to put our label or the text that comes about the boxes, we say cv2 dot put text. And now we again have to give it a bunch of inputs. So first of all, the image. So image. And then we need, so now over here we're going to put the text. So what text are we going to put? So first we have the name of whatever object is inside the box, which is going to be label. And then we're going to add some gaps, so some space. And then we're going to have another variable, which is the confidence value or the accuracy value. And then we have we have to tell it where it's going to be located. So I'm simply going to put x value and y value. And then we have our font, which is again going to be our font. And then we have the size or the font scale, which I'm going to use 0.5 based on prior experience, or 0.4. And then we have the color. I'm just going to make it a greenish, light green color. And then we have thickness, which is going to be 1, and we don't need the line type or bottom and left origin. So let's again space this out. So now since we have all of that, what we're finally going to do is we are going to run this. 3, 2, 1, go. Okay, so there is an error. So as you can see, it says invalid index to scalar variable. So what does that mean? Well, let's look at our code. So do you notice anything wrong? Well, whenever you get an error, the best thing I have is just look at all of the variables. Look at them and see if all of them are correct. So do you see where I went wrong? I just typed in class IDs, whereas the array name I assigned was class IDs values. So whenever you get errors like these, the best thing to do, or what I do, is I just review all the variables and all the input values I've given it, and I'll just check if all the input values are correct or wrong. Now we should get it, hopefully. There we go, guys. As you can see, we have all of our objects detected. So let's actually modify that. I'm going to make that 0.3, and let's make all the color black, and let's run that again. So I know it's not that clear, but I hope you can read it. So you can see it says potted plant, clock, vase, chair, keyboard, TV/monitor, TV/monitor, and TV/monitor. Now, how cool is that? Yes, I know it didn't detect everything like this chair over here, but you can do that by just giving the computer more practice. And by more practice, I basically mean by giving the computer more pictures to look off of. Now, this is the end of the video for the people who want to basically do object detection on images. But if you want to do object detection on videos or on using your webcam or a camera, well, that's also quite easy. And we're going to do that in this part. So if this is all you want, then thank you for watching. Have a nice day. But we're going to move on to the live recognition part. For the live recognition part, using our camera, it's actually really easy. And if you want to recognize images from maybe like a video, then that's also easy. I'll show you how to do that too. So we have to do some minor changes. Like for beginners, we don't need an image, so we're gonna comment out the image variable, and we actually need a video. So we're gonna say vid equal to cv2.cap get image, or get cv2.get video, which should be somewhere over here. Video capture. So we're going to say cv2.video capture. And inside here, you're going to type the name of your MP3 file or the video file. But since I'm going to be using my webcam, I'm simply going to type 0. So this means to access the main camera. Now, over here, what we're going to do is, under here in the height and image.shape. So as you can see, we have many errors, but don't worry about that. So don't worry about that. We'll fix all of those in a second. So what we're going to do is we're going to write while true, and then we're going to indent all of this from height and the width until the weight key over here. We're going to indent all of that. Now we're going to make some minor changes. Like over here, we are going to type underscore image. And what we're going to do is we're going to basically make our live feed into frames. And we're going to get that frame, and we're going to get each frame converted into an image. And we're going to detect that image and put it back and combine all of that to make a video. So we're going to say image equal to cap.read. So as you can see, there's actually a little error. It doesn't know what cap is. So it's not cap. As I said, this is going to be our variable name. So our variable is vid. So vid.read. Now, that should be one of our changes. And then our second change is going to be, we're going to go all the way down here. And what we're going to do is, over here, where we say for I equal to indexes.flatten, we are going to write a simple if condition. So if we're going to say if len of boxes, or in our case, boxes, len of boxes. And then what we're basically going to do is we're going to say greater than 0. And then we're going to indent the whole for loop. So we're basically going to indent this for loop, which goes all the way until here. We're going to indent that. Now, after we have indented the for loop, we are going to make one last final change. So I'm going to enter that. And we're going to say, number 1, we're going to say key equal to CV2. And we're going to make our weight key 1 because this is going to be a video. And we're going to say if key, actually no, we don't need this. So all you're going to do is we're going to say cv2.weight key. So this is how we're going to make a video live feed. Now let's test it, shall we? So using the live webcam is actually really easy on, like a monitor when you have an actual webcam, but on laptop, it's kind of hard to capture a big picture. So what I'm basically going to do is I'm going to put in front multiple objects, and the camera is going to detect it. So first of all, let's run our program. And as you can see, it has detected the chair. Now if I put my hand in, it should be able to detect me. So as you can see, it has detected me. It says person 1 right up there. And now I'm also going to put up my phone, which it should detect as a phone. So you can see it says cell phone. And now one last thing that I'm going to show is a book, which it should detect as a book, I think. So yeah, as you can see, the video is kind of glitchy. That's because I'm using the YOLO version that's not known for its speed. But if you use the YOLO Tiny, it should be faster. So you can see it says book. And then the cell phone. And you can test it out with all the objects that YOLO v3 can detect. So now let's stop this program. So that's the code. I'll post all the links for where to download and everything else down in the description below. And I'll also post the source code. Thank you for watching. And if you like this video, please leave a like down. That would mean the world to me. And please subscribe if you want more content like this. If you have any questions, put them down in the comment section below. Again, thank you for watching. Have a nice day. And check out these videos. They're from my channel, and well, YouTube thinks you would like them. Again, thank you for watching. Have a nice day. Bye.